Well, hello everyone. My name is Stephen Thomas, and have a look at what we've got here today. We've got a little board, and on the board are these little chappies. Now, what are these little chappies? They're some electronic component. And we've got here 1, 2, 3, 4, 5 of them, and there we've got 1, 2, 3, 4 of them. Here we've got 1, 2, 3 of them, and then we got 2 of them. Now, when these little chappies, first of all, you see they've got these little rings on them, and they are known as resistors. Now, I'm colorblind. Those little rings tell you what the resistance is. But being colorblind, I can't read those colors. They all look the same to me. So we've got a means of telling what the resistance is. We've got here a thing called a multimeter. And if we turn it to around about the 7 o'clock mark, if this was a digital analog clock, it's going to measure the resistance in ohms. Let's see what each of these little chappies' resistance is. So, taking any one of them, do you see it says it is 100, these are 180 ohm resistors. So each of them, if you look at them, they're the same. So there's 180, 180, 180, 180, 180, 180, 180. They're all 180. Do you see how they're arranged in rows? Now, when resistors or any component is arranged so the current flows through it, then the next one, then the next one, then the next one, in a series of events, we call that the components are connected in series. Now, this lot of series is in parallel with this lot of series, but we're only going to look at one row at a time, and I've got a means of doing that. Now, if these resistors are in series and each is 180, just have a look. If we have 180 plus 180, what do you see it reads? It reads 360. 360. That's 180 plus 180. And if we have 3 180s, we're measuring between the probes, it's 540. It's 3, if you do the maths, 3 times 180, and 4 times 180, about 720, and 5 times 180, about 900. There, do you see that? 5 times 180 is 900. So resistors in series, you find that you add their resistances. So the total resistance for all the resistors together would be 1, 2, 3, 4, 5 times 180 is 900 ohms. 4 times 180, 3 times 180, 2 times 180. Now let's connect up a circuit. So here we've got a battery box, and they say that that resistors in series, let's first have a look at these two. They say that resistors in series are voltage dividers. So let's set this up to measure in volts. So now we turn it to the 20 there. There's the arrow to 20, and we're going to measure up to 20 volts. So we've got our battery box. Let's connect up. There's the positive. There is the negative. And they say that resistors in series, now here we've got only 2 resistors in series, are voltage dividers. Let's have a look what the total voltage is between. So here's the current. It's going to flow through here. It's going to flow then through one resistor, through the other resistor, through this wire back. So all the rest of the series are being ignored because these are open circuits. Electricity can only flow through a closed circuit. So let's measure what's the voltage across. Approximately 5.96. And resistors in series are supposedly voltage dividers. So they say, there's 2 of us. The total voltage is 6. Each of us must drop the voltage 3 volts approximately. Let's have a look. 2.99 is 3 volts. 2.96. 2.96. So each one has dropped it approximately half. Now, I just want to take this out for a moment. Switch it off. And let's take this wire off. And let's connect now 3. There's 3. Let's connect it to this chain. So here the current's going to flow from the positive through 1, 2, 3 resistors. And they're still in series. Now it's going to ignore that's an open circuit, open circuit. The current is going to flow purely through this one. Then it's going to flow up and back to the battery. Okay, so let's complete the circuit. I'm just going to put one more wrap around it just to make sure that it makes a nice, good contact. So if this is 6 volts between there and there's 3, what is 6 divided by 3? How much am I expecting each resistor to drop the voltage by? Well, let's have a look. I'm expecting it to drop it by 2 volts. And there it says 2.02. Now, if that drops at 2 and that drops at 2, I'm expecting the total drop to be 4. And then 3 would drop at 6 volts. So each is dropping at 2. If I measured any 2 of those, it's going to be about 4 volts. Any one of them is going to drop at 2 volts. Okay, now let's try that again. Let's try it with 1, 2, 3, 4 resistors in series. So now I'm going to connect this. I'm going to make this the closed circuit. Ignore all the others. It ends there. It's open, open, open. What is 6 divided by 4? 1, 2, 3, 4. 6 divided by 4 is going to be 1.5 volts. I'm expecting that each one of those resistors is going to drop it by 1.5 volts, or 6 divided by 4. 1.5. 3. What do you expect? If that's 1.5 plus 1.5 plus 1.5, 4.5. Okay, 4.55, and then it's going to be 6. So approximately. So when we've got 1, 2, 3, 4, the total voltage divided by 4. When we've got 3, the total voltage divided by 3. When we've got 2 only in the circuit, the total voltage is divided by 2. So if we've got 6 volts divided by 2 resistors, each one's going to drop at 3 volts. If we've got 3, it's going to drop at 2 volts. If we've got 4, each is going to drop at 1.5. And if we've got 5 resistors, it's going to be 6 divided by 1.5, which is about 1.2 volts. So resistors in series are voltage dividers, and the total resistance of resistance in series, you just add 180, 180 plus 180 plus 180, and you get the total effective resistance of the circuit.